In this video, we are going to solve this question from electrostatics. The question is two dipoles of dipole moments P1 vector and P2 vector are separated by a distance r. How does the force of interaction between them vary with r? So it is given that we have two dipoles having dipole moments P1 and P2, and the centers of the two dipoles are separated by a distance r. So we have to find how does the force of interaction between the two dipoles vary with the separation between them, means dependence of force on r. So let us solve this question. So suppose we have two dipoles like this. This is P1 vector, the first dipole moment P1 vector, and this is the second dipole moment, it is P2 vector, and the separation between their centers is given by r. Now we have to find how does the force of interaction between them vary with the distance r. So we know that each dipole produces electric field, and the electric field varies inversely as the third power of the distance. So let us find that what is the electric field produced by this dipole at this position. So E1 will be equal to, if it is axial point, then it will be k into 2p1 by r cube. If it is equatorial point, if I place the dipole like this, then this one will be at the equatorial point. So that doesn't matter, because axial point and equatorial point, at both the points the electric field will vary inversely as the third power of the distance. So E1 is equal to k into 2p1 by r cube. Imagine that this is the axial point. So due to this electric field, the dipole will experience a force. Okay, and obviously we know that when a dipole is placed inside electric field, it has some potential energy, and we know that the potential energy stored in a dipole is given by the formula minus p vector dot e vector, or minus pe cos theta, minus pe cos theta. Okay, so due to this energy, from this energy we know that this is a conservative force. Electric force is a conservative force, and once we find the potential energy, we can find what is the force by using the formula F equal to minus du by dr. So let us find what is the potential energy stored in the second dipole due to the electric field of the first dipole. So the energy will be minus p2 vector dot e1 vector, minus p2 vector dot e1 vector, that is equal to minus p2. What is e1? e1 is k 2p1 by r cube into cos theta. So since I am interested to find how does the force of interaction vary with the distance, I will ignore all the constant quantities. This k, 2p1, p2, cos theta, I will ignore them. I will just look how does the energy depends on the distance. So u is found to be proportional to 1 by r to the power 3. Is that clear? Okay, so let us write that u equal to some constant c by r to the power 3, and with a negative sign, because we have a negative sign here. So what does what is the relation between force and energy? F equal to minus du by dr, that equal to minus of d by dr of what is u? U is minus some constant c divided by r to the power 3. So minus minus will become plus. So it will be like taking c outside, we have d by dr of r to the power minus 3, that will be minus 3 into r to the power minus 4. So force is equal to minus 3c divided by r to the power 4. Again this 3c is a constant quantity. So we got to know that the force of interaction between the two dipoles separated by distance r varies inversely as the fourth power of the distance between them. So in this way you can solve this question.